In this video, we are going to discuss indefinite integrals and the net change theorem. So first, the difference between indefinite and definite integrals. An indefinite is going to be a general antiderivative of a function. So indefinite does not start and stop a very specific point. It is a very general term, and you're going to have plus c at the end of any integral, because when you take the derivative of a constant gave you 0, which means you're not sure if there was a number that was attached to the original function. A definite integral is going to actually begin and end at very specific numbers, which means you're going to get an actual number as an answer. There is not going to be a plus c because you're physically stopping at a certain point. Now, here is a general integral list that you can pause the video and write down if you want to, but these are very general antiderivatives that we will use on a regular basis. So, to find the integral of a specific function, you're going to take the integral of it, and then it's going to be plus c. Okay, now you have to understand in this case, because you cannot have 0 in the denominator, then it is going to be valid only from 0 to infinity or from negative infinity to 0. It cannot include 0, but it can be any other numbers possible. So for example, if I want to find the general indefinite integral of this function, the answer is going to be the integral of each one separately. So I can actually take them separately if I want to. I can break them apart. I can break them apart, and I can even go a step further by taking the constant out front. X to the 4th becomes an x to the 5th, but I have to offset it with a 1/5. Because there was a 10 in front, this 10 and 1/5 give me a 2x to the 5th. Secant squared, according to the above list, secant squared is tangent. And the 2 constant out front just stays. It just comes down with it. Any constants will just come down. And now we do a plus c. We don't need a plus c for both integrals. This plus c is just represented by any possibility that there was an actual constant number as a part of the original function. So you would just put a plus c at the end. So in this case, we want to find the general indefinite integral for this. So there's a couple of ways we can do this. One, we can rewrite this as cosine over sine times 1 over sine of d theta, which is the exact same thing as cotangent times cosecant. And cotangent times cosecant is actually going to be a negative cosecant. Of theta. But don't forget, because we're looking for the very general term, it's going to be plus c. Next, we can separate this out or put it together or keep it together. So x cubed is going to be an x to the 4th, but I have to offset this 4, so I got to make it a 1/4 in the front. And then this x becomes an x squared, but I have to offset it with the 1/2 This 1/2 in that original 6 is going to be a 3. And let's check to make sure. 2 times 3 is 6, and that becomes 6x, so it did work. And I'm going from a 0 to a 3. So I'm going to plug in 3 into x, and then I'm going to plug in 0 into x, which is just going to give me 0. So I'm going to get 81 over 4 minus 9 times 3, which is going to be 27. So 81 over 4 minus 27 is going to give me a negative 6.75. In this way, we're going to do the same thing, except you got to be careful on this one because the curve goes down underneath the graph and then it goes back up. You actually are going to have multiple areas that you need to combine. If we were to take the straight going from 0 to 2, so x cubed is going to give me an x to the 4th, but I got to offset it by a 1/4. This 1/4 and this 2 is going to be a 1/2. And again, if I take the derivative, 4 times a half gives me the 2, so it did work. Negative 6x is going to be negative 3x squared. And then this right here (1 over x cubed plus 1) is the inverse tangent. So this will be 3 times the inverse tangent of x. And we're going from 0 to 2. So what we're going to do is we will have 1/2 times 2 to the 4th minus 3 times 2 squared plus 3 times the inverse tangent of 2 minus all of that to the 0. Because if you plug in 0 into every one of these, you actually do get 0. So if I was to put this into the calculator, I will get negative 0.679. And what is happening, the reason this is going to be a negative is because if you look at this graph over here, the amount of area that is underneath the x-axis is greater than the area that is above the x-axis, leaving you with a negative area. Now, the net change theorem, basically, it's an integral of a rate of change. That would be the net change. So if I take a function's derivative, then it is going to be the integral of the original function from b or from a to b. So for example, if the volume of water in a reservoir at time t, if we know the volume, then its derivative is going to be the rate at which the water is flowing into the reservoir. And so to find the integral of the derivative, they're going to cancel each other out, leaving you the function from the final time and the initial time. There are other ways you can see this. We talked about the volume. You also have like a chemical reaction. And if a function c of t is a concentration of product, then the derivative of the function is basically going to be the function from your final time and your initial time. That's going to be the change in concentration. If you had the mass of a rod measuring from left endpoint to a point somewhere else, then the linear density is going to equal the derivative of the mass of the rod. And so therefore the integral of p of x is going to basically be the exact same thing as the function, the mass function from a to b. The rate of growth in the population is going to do the exact same thing. It's the net change of the function during the time period. Cost of producing X units of a commodity, the marginal cost is going to give you, again, the exact same. When you take the derivative, if you take the integral of a derivative, it's going to give you the original function that you are going to subtract the initial from the end result. So for example, let's say a particle moves along a line so that the velocity is that function and it's measured in meters per second. We want to find the displacement of the particle, and then we want to find the total distance traveled. So first, to find the displacement, what we are going to do is we're literally going to find the integral from 1 to 4 of t squared minus t minus 6 of dt, because that is the variable that we're taking the derivative of, or the integral of, sorry. So the integral is going to be 1/3 t cubed minus, that's going to turn into a t squared, so I need to offset it by doing a half, and then any constant is automatically going to be that times the variable, and I'm going from 1 to 4. So I'm going to plug in 4. And then I'm going to plug in 1. And when I do that, I will get a negative 4.5. Means you have gone in overall from 1 to 4, you have actually gone in reverse order, negative 4.5. So what's happening is we are going to actually graph this to show what is happening from 1 to 4. If I was to graph this, I'm going from 1, which is about right there, to 4, which is about right there. So what I'm doing is I am finding the area of this curve from 1 to 4. It is definitely the area below the x-axis is more than the area above the x-axis, hence, which is why we get a negative with the total displacement, which means we are starting underneath, we're going home, and then we're going away from home. So what's happening though, for the total distance traveled, is what I have to do is I have to figure out what is this total distance traveled from here to here as an absolute value. Even though I am traveling in a negative direction, I am still traveling that distance. And then I need to know what that is to what this is as an absolute value as well. And then I'm going to add these two distances apart. So what I'm going to do is, since it crosses the x-axis at 3, what I'm going to do is I'm going to take my function and I'm actually going to go from 1 to 3, okay? Take the absolute value of that answer, and I'm going to add that to the absolute value as going from 3 to 4. And here's why. The actual distance from 1 to 3 is going to be negative. That's why I need the absolute value of that, because even though it's going to be a negative number, I still traveled that distance. And I'm going to add that to the distance from 3 to 4. Once I get those and add them together, then I will have a final answer. So this one is going to be negative 7.33, but I need the absolute value of that. So it's going to be a positive 7.33 because I still traveled the distance even though it was negative. And then this next one is going to be 2.8 repeating. So now that I have the actual distance traveled, I can now add them together, and my final answer is going to be 10.17. So the difference between displacement and distance. The displacement is just going to be the difference between those two numbers. Basically, how much did you travel? Sorry. The displacement is basically your net change. But the total distance traveled is going to be the actual distance, whether you add up the negative amount that you traveled plus any positive amount that you travel, and you combine them together. And it basically will tell you how much total distance you traveled overall. So to recap, attempt these problems and then hit resume to see the answers. For the first one, think of this as x to the 5/4. So therefore, the general integral is I'm going to add 1, which is going to be 9/4. But I need to offset it. So it's going to be 4/9 times x to the 9/4 plus c. All general integrals must have a plus c. I'm going to rewrite this as 1/2 x minus 2 times 1/x. Okay, so this is going to become an x squared, which means to offset it by a half. But that half and this half is going to give me a 4th. 1/x is natural log of x. And I'm going from 1 to 2. And I will get a negative 0.64. Calculate the shaded area between the curves. So I am looking for the area of this shade. I'm going x equals and x equals 0. So I'm going from where it crosses the intersection. So I'm going from 0 up to 2 of 2y minus y squared. In this case, it is going to be dy. So to find the integral, it is going to be y squared, but I have to offset it by a half. So 1/2 and this 2 cancel. And then it's going to be y cubed, and I have to offset it by a 1/3. And I'm going from 0 to 2. So I'm going to get 2 squared minus 1/3 times 2 cubed minus 0. And I will get 1.3 repeating.